It's asking us what is the length of side RS in the figure shown below. So it looks like I've got a couple of different triangles going on there. So the first thing I see is a 45, 45, 90 right triangle. I know in a 45, 45, 90 that the hypotenuse equals the leg times square root of 2. So I know I'm going to put 12 in for my hypotenuse. I'm going to put square, and I'm just keep it leg square root of 2. So I'm going to take and divide by the square root of 2 equals the leg. I could rationalize that, but I'm going to choose to wait and just see what happens. So see, maybe I don't want to, that way maybe I don't rationalize a couple of times in the problem. Now on this other triangle, I have a 30, 60, 90 right triangle. I know across from the 30 is the short leg, across from the 60 is the long leg, and across from the 90, of course, is the hypotenuse. So I need to get the hypotenuse. That's what I'm looking for. So I have the long leg. I know that the long leg equals the short leg times square root of 3. And I know that the hypotenuse equals the short leg times 2. So I'm going to have to get to the short leg. So I'm going to put this 12 over square root of 2 in for the long leg. And then I'm going to divide by square root of 3 or multiply by its reciprocal 1 over square root of 3. So when I simplify this, I get 12 over square root of 6. So that's my short leg. I'm going to put it into this formula. So my hypotenuse, or RS in this case, equals my short leg, 12 over square root of 6 times 2, which equals 24 over square root of 6. Now, likely your answer is not going to have a radical in the denominator. At this point, I'd go ahead and rationalize it. So I get 24 square root of 6 over 6. I know 6 goes into 24 4 times. It's possible when you do this reduction, you might not get the number in the denominator to divide all the way into the numerator. You might just be able to reduce the equivalent fraction.